In the previous example, we asked what would the force, the electrostatic force, be on two protons, one separated 1 meter from each other. Now we're asking the question, what is the gravitational force? So we have two protons like this separated by 1 meter. Now they would be attractive. It would be an attractive force. Like so. Well, that force of gravity, big G, big M, little m over r squared. So that's 6.67 times 10 to the minus 11th. Times the mass of the proton. The mass of the proton is 1.67 times 10 to the minus 19th, minus 27th. And there are two of them. And again, we see there isn't a larger one and a smaller one. There's just the two of those. And again, being over 1 meter makes the calculation a lot easier. Putting our numbers together, we get 6.67 times 1.67 times 1.67. And then 10 to the minus 11th, 10 to the minus 27th, 10 to the minus 27th. And doing an estimate, well, this would round to 7, and 2, and 2. So 7 times 2 is 14, times 2 is 28. So we're looking at about 28 times 10 to the minus 54th, minus 65th. Or about 2.8 times 10 to the minus 64th newtons. Very small number. And then if we were to ask about the acceleration, well, the net force is ma, and that acceleration is caused by gravity. And so we're looking at 2.8 times 10 to the minus 64th, all over 1.67 times 10 to the minus 27th. Estimate, this would be about 3, and this would be about 2. So we're looking at about 1.5 times 10 to the minus 37th meters per second squared. Now I'm just dividing that out. Gives us 1.677. Times 10 to the minus 37 meters per second squared, or about 1.7 times 10 to the minus 37th meters per second squared. So this is the force. Now to accelerations. And the last question is, how do they compare with each other? Well, let's put them side by side. So here's our gravity, which was 2.8 times 10 to the minus 64th newtons. And the acceleration was 1.7 times 10 to the minus 37th meters per second squared. And electric force, the electrostatic force, 4 times 10 to the minus 30th, and 1.4 times 10 to the third. So if we look at these, both numbers are very, very small in terms of the forces. But we cannot lose sight of the fact that the electrostatic force is 10 to the 34th times larger. So picture that. You have $1. What would it mean to have wealth that's 10 to the 34th times larger than that? $1 trillion is 10 to the 12th. So the idea, the difference here in the forces are unbelievably, unimaginably different from each other. And when we look at the accelerations, this is accelerating at 1,000 meters per second squared. This, the gravity, 10 to the minus 37th. And so the acceleration is about 10 to the 40th times larger. A very large difference indeed. So for this reason, people very often say that gravity is a weak force and electrostatic is a much stronger force. Electrostatic force is much stronger than the gravitational force. And that doesn't fit our life's experience very well because the dominant force in our lives is gravity. And we understand how significant that is. But the electrostatic force is vastly stronger in terms of its force and its effects.